everybody. Hope you're ready to flex those brain muscles and make some brain gains. Today we're going to learn about how to add and subtract radicals or radical expressions. So let's go ahead and get right into it. We have 2 square root of 3, and what this really is multiplication. This is 2 times square root of 3. It's like an invisible times symbol. It's just implied. It's kind of like putting 2x, right? That's 2 times x. We just don't write the times to save time. All right, so 2 root 3 plus 3 root 3. So what this really is this is root 3 plus root 3. Because that's what 2 times root 3 means, right? It means root 3 2 times. And this is 3 times root 3 plus root 3. So that's just root 3 3 times, right? So what we have total is 1, 2, 3, 4, 5 root 3's, right? Root 3 5 times. So what do we notice here? Is there a pattern? Let's see. Well, this 5 is this 2 plus 3, right? And all we did was we kept the radical, we left it alone, right? So what's another way we could think of this? Well, what if we say root 3 is kind of like the x? Remember when I said this is kind of like 2x? And we could write this as 2x plus 3x. Well, that's just 5x. You could probably do that just by looking at it, know that. And this is the same idea. These root 3's are the same thing, and just like x is the same thing, right? So we're adding 2 times this thing plus 3 times this thing, which ends up just being 5 times this thing, right? Make a little bit of sense? So for this part, I could write this out like this, and it would be root 3 plus root 3, and this would be root 2 plus root 2 plus root 2, right? But what do we notice right away is that we have 2 different things. This is root 3, this is root 2. This is kind of like seeing something like this, 2x plus 3y, right? Which we would look at this and we'd immediately say, well, that's it. They aren't like terms, we can't combine them. Well, that's the same in this case. These are 2 different things. It's kind of like apples and oranges, x and y, however you want to think of it. There's 2 different things, so we can't combine them. This is actually as simple as this can get, right? So in general, they have to be the same thing under the radical to be able to add or subtract them. To be able to combine them, it has to be the same thing under the radical. All right, so you're probably looking at this and you're thinking, this goes against what you just said. These are different things under the radicals. This is as far as we can go. But now we know how to simplify radicals, right? And if you don't, you can click this video up here. We simplified a bunch of radicals. So we can actually simplify this, and we can sometimes make this the same thing once we simplify. Okay, so let's see how this works. What does 12 break down into? That's 4 times 3, right? And 4 is a perfect square. So we can rewrite this as 2 times root 4 times 3 under here. And what about this 27? What can this break into? I'm looking for something that's a perfect square like that. And I think it's going to end up being 9. 9 times 3, right? Well, the square root of 4 is simply 2. So the 2 comes out. And when that 2 comes out, it actually multiplies with this 2. So I get 4. And this 3 just stays in the root. 3. Sorry, that's a bad 3. There we go. Minus. Same thing happens here. That square root of 9, that's really just a 3. The 3 comes out. And it multiplies with this 3, because this 3 is just hanging out here. The 3 comes out. It joins that 3. They become 9. And this stays the root 3. Oh, look what we have here now. 4 root 3 minus 9 root 3. Now we have the same thing under the radical, right? And this simplifies. We just simply do 4 minus 9, which is negative 5. Right? 4 minus 9, negative 5, root 3. There we go. So we've seen that not in all cases, you have to do some investigation before you can just say, oh, these won't combine, these won't simplify. You have to do some investigation and see if you can simplify it to make them be the same thing under the radical so you can combine them. Okay, so 2 root 18 minus root 8, we're going to do the same thing. So we're going to break this up into 2, and under here is going to be 9 times 2, right? 9 is a perfect square, minus, what do we have here? 4 times 2. 4 is a perfect square. So this 9 comes out as a 3, and it joins this 2. 3 times 2 is 6. So that's 6, and I'm left with the root 2 in there, minus. Same thing with this 4. It comes out as a 2. And what's left in the radical? Sorry. root 2, right? So 6 root 2 minus 2 root 2, that gives us 4 root 2. All right, for these examples, same thing. Our radicals are not the same, so we're going to do a little bit of simplifying, and we're going to see if we can make them the same so we can add these. So first off is 54. How can I break this 54 up? Well, 54, let's see. That is 9 times 6, right? 9 times 6. And what about this 96? And sometimes when you have these bigger numbers, again, you can make a little side note, 96. And you can kind of break this down. Do a little, well, I'll do a tree. That's how we normally see it, is as a little tree. So I'm 96, and I'm going to break this down. So what about 48 and 2? And then what can I break 48 into? Let's see, that's 4 and 12. And what about 12? That's 4 and 3, right? So I can take out basically a pair of 4s. So basically I'm left with what? 16, because that 4 times 4 gives me the 16 times 6. Right, so sometimes you have to make a little bit of side work, and maybe you don't have to. Maybe you could have looked at this and immediately said, oh, that's 16 times 6. But maybe you couldn't, and it's okay that if you have to do this little tree to the side. So now that I've rewrote this, I can pull the 9 out as a 3, so that 3 joins this 2. 3 times 2 gives me the 6, and I'm left with the root 6 inside. Plus, same with the 16, it comes out as a 4. Square root of 16 is 4, right? And I'm left with root 6. 6, root 6 plus 4 root 6, that is 10 root 6. There we go. All right, this next example. Now we got x's involved, but it's the same idea. Don't panic. It's the same idea. So we're going to break this down, and we're going to see if we can make these radicals look the same so we can combine these. So what can I take out of here? Let's see. This is just 3 root 4 times 2 times x, right? That's how I can separate this. 4 times 2 times x, and that 4 can come out. Minus 6, and what is this 32? What can I pull out? I can pull out a 4. Let's see, 4 times 8. But I can pull out another 4 from that 8. So let's break this down fully. Let's see, 32. What can I pull out? 16 times 2, right? 16 times 2 times x. See, and even I sometimes have to do a little bit of thinking, a little bit of investigating. You don't always see it right away. That's okay. So 16 comes out as a 4. Well, let's start from here. We'll go from left to right. So the 4 comes out, it becomes a 2, and it joins that 3. 3 times 2 is 6. And I'm left with 2x inside here. Minus, this 16 comes out as a 4. 6 times 4 is 24. What am I left with in here? 2x. Now I have the same thing under the radical. Now I can combine these. 6 minus 24, that's just negative 18. And I still have that 2x under the radical. All right, last example. What if I have cube roots? Well, it's the same idea. They have to be the same thing under the radical regardless of what kind of root it is. This could be a 7, it could be a 3, it could be a 20. It doesn't matter. They have to be the same thing under here to be able to combine them, right? So let's see if we can make these look the same. So we're trying to basically take out a perfect cube from both of these. So let's see, what are our perfect cubes? We have 8, that's 2 cubed. And I think that's actually what we can use for this one, right? 8 times 3 gives me 24. So what if I split this up into 2 cube root of 8 times 3? And what can I split this up as? This is going to be cube root of what? Let's see if I can pull out maybe an 8. No, let's see. What are my other cubes? Let's see. 2 cubed is 8. 3 cubed is 27. I think that'll work. 27 and 3 gives me the 81. And again, if you didn't see that right away, you could have done a little side work here and you would have got to it eventually. So 8 comes out as a 2. This becomes 4 root 3, cube root 3. Plus 27 comes out as a 3. This becomes 3 cube root 3. And this simply equals 7 cube root 3, and that's it. So it's actually the same idea, regardless of what kind of root it is. It's the same idea. So hopefully this video helped. Again, it's just a bunch of simplifying. You get the radicals to look the same, then you can combine them. So hope this helped. Leave questions below in the comments. Hit the like and subscribe button if you enjoyed, and we'll keep making those brain gains next time. See ya.